Hello students, in our last class we completed the electronic configuration and the electronic diagram for it. Now today we are going to see new topics. Say for example, first we'll discuss about valence electron. Valence electron means the number of electrons present in the last orbit or the outermost shell are called valence electrons. Okay, say for example, in case of sodium, the electronic configuration is written as 281, so 1 is the last electron, so valence electron will be 1. Okay. Now valency is also defined as the number of electrons that takes part in a chemical reaction. Similarly, if the elements have got 1, 2 or 3 electron in the valence electron, their valency will be 1, 2 and 3. And if the element contains 4, 5, 6 and 7 valence electron, then its valency will be 4, 3, 2, 1. Okay, so this is regarding the valence electron. Now why there need to be a chemical activity of an atom? That means why an atom show chemical activity? All the atoms need to stable, so for stable they need to have 8 electrons in the outermost shell, and if it is only the first cell it needs to have only 2 electrons. Okay, based on that we have got two important rules, octet rule and duplet rule. We'll see that rule. Okay, so the electronic configurations of inert gases, if you see, then for helium it is only K2, neon it is 2 8, first K 2, then L 8, similarly argon 2 8 8. Okay, similarly it goes on. Now if you see this element, they are very unreactive, that means they are very stable compounds. Okay, so and except this helium, all the elements have got 8 electrons in the outermost shell. All the elements have got 8 electrons in the outermost shell. So for stability of an atom, it should have 8 electrons in the outermost. Okay, so according to octet rule, it states that for an atom to be stable, it must have 8 electrons in the outermost shell, except the first K cell which contains only 2 electrons. That is octet rule. And duplet rule states that for an atom to be stable, it must have 2 electrons in the first K cell, and the structure is like that of helium. So this is octet and duplet rule. Now why do atoms need to combine? As I told you, all the atoms need to be stable. Okay, so for that atom needs to combine. So for stability what they will do, they will either transfer or they will share an electron. Based on this we have got further studies about it. So the elements just combine with other element to have inert gas structures. Okay, like that. It want to contain in the last electron 8 electrons. That is the reason. Chemical bond, there is a term called chemical bond. A chemical bond means the force of attraction between the two atoms which hold them together as a unit is called a chemical bond. Okay, say for example in hydrogen molecule H2, we have got two hydrogen atoms attached to each other by a force of attraction, that we call it a chemical bond. Next we have got isotopes. Isotopes of an element, isotopes of an element is defined as atoms of the same element having same atomic number but different mass number. Okay, atoms of the same element having same atomic number but different mass number. Say for example hydrogen has got three isotopes, H11, H12, H13. So these are the three isotopes of hydrogen. If you see, all the elements are same, the atomic number is same, only the mass number is different, 1 2 3. Similarly carbon has also got three isotopes, C12, C13 and C14. Chlorine has got two isotopes, C35 and Cl37. Okay, so these are the examples of isotopes. So atoms of the same element having same atomic number but different mass numbers are called isotopes. Next we need to discuss about radioisotopes. Okay, radioisotopes. So radioactivity means it is a process in which the heavy elements will break down, or it is a spontaneous decay or disintegration of a substance to give alpha particle, beta particle and gamma particle. Okay, now the isotopes involved in radioactivity, they are called radioisotopes, and the examples of radioisotopes are very important in medical field. Say for example, cobalt is used in radiotherapy for treating cancer and other diseases. Okay, C14 is used for determining the age of historical and geological material. An isotope of urine is used as fuel in nuclear reactor. Similarly, an isotope of iodine is used in the treatment of goiter, okay, which is the iodine deficiency disease. Next thing we need to discuss about isobars. Like isotopes, we have got isobars. Isobars means atoms of the different element having same mass number but different atomic number. It is just the opposite of that. So example we have taken is argon and calcium. If you see, their mass numbers are same, 40 40, but their atomic number is different, 18 and 20. Such are called isobars. Okay, similarly we have got chromium and iron. Okay, chromium 54, here also 54, and atomic number 24, here it is 26. So they are called isobars.